Here's number 4 from section 4.3. Our instructions are to use the first derivative test to determine the local extreme values of the function and identify any absolute extrema. We're going to support our answer graphically. I'll leave that part to you. We're just going to do the paper and pencil part for number 4. Here's the function. Y equals x times e to the 1 minus x. So for the first derivative test, obviously we're going to need the first derivative. So let's get started with that. Y prime is equal to x e to the 1 over x is going to use a product rule. So we're going to take the first function, x, and multiply by the derivative of the second. So the derivative of e to the power of 1 over x is first itself e to the 1 over x. And then by the chain rule times the derivative of 1 over x. So you might think about this over here in some white space. The derivative of 1 over x is the same as the derivative of x to the negative 1 power. So that's negative 1 x to the negative second, or negative 1 over x squared. And that's what I'm going to use here, negative 1 over x squared. Then we say plus the first function, e to the power of 1 over x, times, that's the second function, times the derivative of the first, which is just 1. Then we want to simplify this a bit. I noticed that the first term is going to have a negative 1 as a coefficient. And you might also notice that this x and one of the two x's in the denominator can cancel. So this first term looks to me like it's going to be a negative e to the 1 over x to the first. The second term is e to the 1 over x. So if we're going to grab the critical numbers of this derivative, we know this derivative needs to be written in one term, not a sum of two. So that requires a common denominator, and it looks to me like that common denominator is just x. We have that in the first term, so we're going to multiply the implied 1 in the denominator of the second term by x, and we're going to multiply the numerator by x as well. And that's going to give us then a first derivative of negative e to the 1 over x plus x e to the 1 over x, and then that's all over an x. All right, one more thing I see we can do is factor out an e to the 1 over x in the numerator. E to the 1 over x comes out. That leaves a negative 1 plus x, or you could write that as x minus 1, and then this is over x. So there's our first derivative in one term. We need critical values, so that's going to be anywhere that the numerator is equal to 0 or the denominator is equal to 0. That'll give us a 0 value, or it will give us undefined. So in that numerator, it looks to me like I have a critical number at x equals 1, because negative 1 plus 1 is 0. E to the power of 1 over x can never be 0, so we don't have anything there. Then we've got a critical value at 0 as well. It makes the derivative undefined. So then let's set up our number line and do our first derivative test. We know this number line goes from negative infinity to infinity. We're going to stick a partition at 0 and another partition at 1. Those are the critical values. And we are testing y prime here. We're testing the derivative. So we get first a test value in the first interval from negative infinity to 0. I'm going to use a negative 1. If negative 1 goes into the first derivative, I'm talking about this simplified version, e to the power of 1 over negative 1 is always positive. It doesn't matter if we plug in a negative 1, a positive 1, 100, negative 100. Whatever we plug into this value in e to the 1 over x, it's going to be positive. A negative number in the x value in that binomial is going to give us negative 1 plus negative 1. That's going to be negative. And then in the denominator, we'll also get a negative value. So a positive times a negative divided by negative is going to be positive. Next, we'll look at the value of maybe 1/2 as a test value. If that goes into e to the 1 over x, we know that's still positive. If that goes into negative 1 plus x, we know that will be negative. And then if we go into x, we will have a positive value there. So it'll be positive times negative over positive, which is negative. Then at 1, we will go to 1 to infinity and pick maybe a test value of 2. That's going to give us positive times positive over positive. That'll be positive. And so it looks to me like then we have a possible value for excuse me, what am I thinking of here? Possible, extrema at 0 and at 1. But quickly, I'm going to throw out 0 as being a possible extreme value. If we take a look at the function again, if we tried to find y of 0, this would give us 0 times e to the 1 over 0. So 1 over 0 fails. That's undefined. So 0 is not in the domain. 0 is not in the domain of this function. So there's no point there. And if there's not a point there, it can't be a relative extreme. So let's take a look at this. We have increasing, we have decreasing, although this is at 0, not an extreme value. Then we increase again. So it looks to me like we have a minimum value where x is equal to 1. So what is y of 1? Y of 1 is 1 times e to the 1 over 1. So that's just e. So I'm going to say we have a minimum at 1, 1. And at least it's a local minimum. We would look at the graph and decide whether that's an absolute minimum. But at least right now we know it's a local. And that's, whoa, I put a 1 in there. That's supposed to be an e. And there we go. That'll do it for question 4.